Folks, there's a man-made cloud that has appeared in the living room. Let me turn off our plant lights so you can see this in its full, devastatingly deadly glory. Oh my God, look at this, folks. This is the thing of legends. The thing of legends. Nothing could be scarier than a man-made cloud. Look at this. This is clearly of demonic origin. I mean, just look at it. It's changing colors. Oh, it must be an electric cloud. Oh, no. Just when you thought it was safe in your living room, man-made clouds appear. Oh, my God. Let me turn the lights back on to reduce the visage of this terrible scourge upon mankind. Man-made clouds, everybody. Oh, my God. Dear God, please save us from the dangers of man-made clouds. Oh, have you ever seen a nuclear cooling tower? They're very dangerous. Ooh, nuclear cooling towers, look out. Watch out, folks. They're evaporating a lot of water and making deadly, deadly man-made clouds. There have been man-made rainstorms, man-made snowstorms, man-made hailstorms, man-made cumulonimbus. Okay, that's enough making fun of the chemtrail cultists. Do we have any Dane Wigington enthusiasts out there? Anybody listening to Dane Wigington? Hopefully not. But if so, we are confident that one day you'll be able to learn how aircraft and weather work. I know, it's a big ask. All right, so I'm at the Smash News Network here. I do have to crank up the desk. So please bear with me. Press the share button. Tell your friends and foes about the channel. Tell people that don't care about you at all about the channel. Isn't that what being online is all about? Impressing people who you don't care about their opinion. There's no better person to impress than someone that you're not concerned about what they think. Pardon my biting sarcasm this morning, but I have ample reason. All right, so are we going to talk space weather? Yeah, briefly. Are we going to talk Earth weather? Sure. Why not? We just put out a short earlier showing that it's 15 degrees here in Lehigh Valley, PA. That's on the cool side. Although not the coolest temperatures we've seen here. We've seen all the way down to, I think we measured 5 with the automotive thermometer. So that was, that's on the cool side. 5 degrees Fahrenheit, that's chill. So yeah, let me break out our SNN console. And by the way, I'm lit by artificial candlelight. I got these LEDs. These things are freaking cool. Look at this. They're just LED candle-based lights, and I got adapters to adapt to a standard light bulb. Standard light bulb, male, with a female candle base. So I can put candle-based bulbs on regular lights. Because with LEDs, it's very convenient and very cost-effective to have some very bright lights that are very small. All right, so, as far as what's going on with the closest star, it's very calm. Solar wind conditions are very nominal. It's not an exciting day for space weather whatsoever. There's nothing new on the way that I'm aware of. There's a big prominence happening down here in the Actually, that happened yesterday. Or was that early this morning? I think that was early this morning. Hold on a minute here. I will rock this back to show you the timing of that prominence. There it goes. That's not likely to have an earthly directed component. It will miss Earth to the southwest in all likelihood. Cool prominence, though. And it's a great example of how we regularly see coronal mass ejections with no solar flare. So, as we say all the time on the channel, please don't conflate solar flares and don't mix. I'll just say this: don't mix up solar flares and coronal mass ejections. They are separate phenomena. Solar flares are photons, so think of like a light, photons, and coronal mass ejections are protons. Think of a fan. It really blows when people don't know the difference between a coronal mass ejection and a solar flare. They just think they're the same thing. They're definitely not. And again, great example here of a major coronal mass ejection and a major solar storm, just not an earthly directed one, right? Will you please click the thing that I'm clicking? Thanks so much. So again, here's that awesome prominence coming out of that southwestern limb. No solar flare associated with it. So yeah, great example there of a coronal mass ejection with no accompanying solar flare. They happen all the time separately from each other. So please don't conflate the two. It's just not good. So the sun's a little warmer than this planet. Let's take a look at some space weather stats here just while we're going through some stuff. How about the cosmic ray report? So there's Oulu, Finland. Oulu, Finland. And as you can see, cosmic ray flux remains at a 20-year low. Last time we had levels this low would be back during solar cycle 23. Solar cycle 23. And by the way, based on the way these graphs look, here's cycle 23 maximum. Here's cycle 24 maximum. Here's cycle 25 maximum. It looks like this is a stronger solar cycle than solar cycle 23. Wouldn't you agree? Let us know in the comments what you think. But certainly in terms of cosmic ray flux, as a function of how much plasma the sun has put out, solar cycle 25 is a stronger cycle than solar cycle 23. So those are just facts. And facts don't lie. Doomsday prophets lie. But, you know, neutron monitors, they don't really lie. Grifters lie. So here is Cygnus X3, the only known cosmic ray point source, located about 32,000 light years away, sort of on the other side of the Milky Way galaxy. Sagittarius A star is about 26,000 light years away, and X3 is about 32,000 light years away. So it's about 6,000 light years farther from Earth than the galactic core. It's in the constellation of Cygnus, and the constellation of Cygnus is one of the most interesting constellations because not only does it contain the only cosmic ray point source, but it also contains the strongest radio source in the entire sky except for the sun. So, you know, just figured I'd share that info with you there. It's called 3C405, a blazar. It's an active galactic nucleus. So that's about 530 million light years away. And that's a stronger radio source than anything from inside the Milky Way galaxy, which is about 100,000 light years in diameter, if you're wondering. So anyway, that's Cygnus X3. Keep in mind, these are not cosmic rays. These are X-rays. But I would focus your attention on this area right here. As you can see, since about 2021, Cygnus X3 has gone into a different pattern here. So that's pretty interesting. However, as of so far, we don't see an accompanying uptick in cosmic ray flux, because cosmic ray flux is determined by solar plasma, not raw from the actual point sources of the cosmic ray flux, because those particles orbit magnetic field lines. All right, let's bring up the Hux forecast here. I suspect it's going to show no more Earth-directed CMEs, and it's going to show one missing Earth to the southwest. Let's see if I'm correct. Looks like about right. By the way, I would also note that this shows additional spacecraft, which is very cool. I mean, I'm excited about it, actually, because you can see right here, here's the Parker Solar Probe, which just made a very close solar pass. You can see the Solo spacecraft here. You can see Stereo A. You can see the ACE and the Discover's at that same location. And of course, it also does show Venus, Mercury. But yeah, the Parker Solar Probe there just a few days ago has made another extremely close pass. Parker Solar Probe is a super interesting object because it's the fastest thing humans have ever built. Sunspot number is way down to 70 sunspots. 70 sunspots is the current state of affairs. Like I said, it's a pretty boring day for space weather, but we'll make it exciting. We'll get you scared about things that don't exist, or we'll find a way to spook you. Okay? Maybe we'll tell a spooky ghost story. A long time ago, in a galaxy far, far away, there was a played-out franchise that nobody wanted to watch. It's called Star Wars. Actually, I've been watching Star Wars, believe it or not. I watched the Book of Boba Fett. Now I'm watching The Mandalorian. I can't stand the Empire or the Rebellion. And there's that CME coming out of the southwest, as forecast. There it is. We do also see some energetic particles striking the aperture here. Right there. See that? That is caused by protons. So that's relativistic particles striking the coronagraph, the GOES 19, the characteristic blocky pattern. Anyway, we don't need to look at Stereo A today. We'll leave that alone. As far as the Space Weather Enthusiast dashboard, this is NOAA's forecast for space weather. As you can see, it is pretty uneventful. A little bit of geomagnetic unrest expected tonight into tomorrow, but that's not likely to produce mid-latitude auroras. However, we hope it is a stronger impact if you are hoping to catch some. Solar wind is nominal right now. We do have an increasing field. At least that's something to report on. Current BTBZ is 7 nanotesla with a BZ of -3. Solar wind density way down to about a half a proton per cubic centimeter here. 0.42 protons per cubic centimeter. Solar wind density 430 kilometers per second. Proton flux remains at baseline levels, so that aperture strike that we showed earlier from the GOES 19 was not accompanied by a measurable solar energetic particle event. That's the GOES proton flux. Background X-ray flux of the closest star has sunk into the B range. So we only have about a B-class background X-ray flux right now. Things are quite calm on the surface of the closest star. Let's take a look at the magnetosphere. I should say the heliosphere. The heliosphere magnetism. We're just going to show today to show the most current. And there is a current sheet approaching, which would be right here at this sector boundary crossing, where in about 36 to 48 hours, Earth is likely to move into a North Pole-oriented magnetic sector. Stereo B has already done that, corroborating this data. As you can see, it has an orange line here, which features magnetic field lines that are pointed away from the sun. See, these magnetic field lines, they point toward the sun. These magnetic field lines are north. They point away from the sun. That's how magnetism works. Next, our line of sight coronal hole plot. There we are. You can see South Pole oriented magnetic features here known as coronal holes, where the field line all the way out into space, all the way to Earth, folks, where they are not measurable from the ground using magnetism because Earth's magnetic field is way, 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 way stronger than the interplanetary magnetic field. Anyway, you can see North Pole oriented coronal holes here rotating in, more trans-equatorial ones, and we can expect an enhanced solar wind in about 12 to 24 hours from this trans-equatorial coronal hole, which is spewing a high-speed wind in our direction. Or you could say those particles are just orbiting those open magnetic field lines. I don't care, but coronal holes are the known source for the high-speed solar wind. That is the high-speed non-coronal mass ejection solar wind. Here is today in magnetogram. And these are not magnetically complex sunspots, so the likelihood of large flares is not there. So yeah, it's a calm day on the sun. Here is the red light imagery. It's actually, we're going to bring up, we'll bring up yesterday and today to show if there's any growth or sunspot reduction. So we do have a little growth up in these groups. Looks like a second group has formed up there. Yeah, that should be a little increase in sunspot number. Expect the sunspot number to go up a tiny bit today as we see more growth than degradation. That's the forecast for sunspot number. Moving right along to magnetic filaments. This is our hydrogen alpha imagery, which shows filaments as dark absorption features. These filaments are blocking our view of the underlying hydrogen. Now you can see in here there's a whole lot of hydrogen where it's white. No hydrogen almost, no measurable hydrogen out here where it's black. In these gray areas, that's the corona. It's pretty rich in hydrogen. Now we do have some great filaments up here. This one could use a name. This one could use a name. And let's talk about naming filaments. Have you ever named a filament after your friends, your foes, or even yourself? Well, here's how to do it. Just go to Twitter, which is still called Twitter, by the way, not X, because we can't call a web service a letter. It has to have an actual brand so that we know what the hell it is. X, that's the letter. You can't brand a thing with a letter. You have to create a brand. Or you could be an utter idiot and you could destroy a known, recognizable, extremely valuable brand. You know anybody who's an idiot who's done something like that? Did you ever see a child buy a toy and then break it? Ever see that? Twitter. It's an echo chamber of science, denial, and nonsense. Yeah, it's super fun. If you want to debate people about chemtrails endlessly and, expose how science illiterate they are, definitely go on X every day. Alrighty then. So this is how you name a filament. Let's do it. So the first thing I'm going to do is I'm going to take a screenshot of this filament. For all of you Microsloth users, to take a screenshot, you just press Shift Windows S. Then you get a little pop-up where you can edit. Okay? Pretty cool, right? Now, I'm going to name a specific filament. Actually, let's go with green. We're gonna make it green. I'm gonna put an arrow here. And that was a really shitty arrow, so that's good enough. That filament down there, actually, let's name this one instead. We're gonna name this filament. Right, now I'm gonna take another screenshot because it puts it in your paste buffer. Yeah, your paste buffer. Did you know that if you press Windows V, it brings up this really cool clipboard menu where it saves everything that's been in your clipboard, at least for a certain period. It's fantastic. Yeah, Windows key plus V. It's great. Anyway, then just go to X, which is still known as Twitter. And type in the hashtag name that filament. Very simple. Then type who you want to name it after. This one's getting named after Scott McIntosh. But so there you go. That's how you do it. You tag me in the post and type in the hashtag name that filament. Then tell us who you want it named after. If that person actually has a Twitter account, then tag that person in the post as well, and I will repost your tweet. So there you go. That filament is now officially named the Scott McIntosh filament. I picked that one because I find that one to be the most likely one to produce an Earth-directed CME. The close second would be this one here. And that is how you name a filament on Twitter. Next, we'll look at the electron flux to see about things like GPS performance. Now, when your GPS has to transmit your location, when your GPS has to detect your location by talking to satellites through a lot of free electrons, signal refraction happens if there are a lot of free electrons. And this is why it's important to know what's going on in the D layer. So I'm sorry, the F layer. This measures the F layer using radiography from an altitude of about 23,000 miles. So just to give you an idea of how high that satellite is compared to the F layer, here's a great diagram in kilometers. As you can see, the F layer is between about 160 and 400 kilometers. Of course, at nighttime, it shrinks down because solar radiation excites the ionosphere. I mean, it excites the whole atmosphere, but we're talking about the ionosphere here, so let's just stick with that. We're not even going to show the ionosphere today because it's, well, okay, we'll show the anomalygram. I'm okay with that. This is anomaly in megahertz from a 30-day median. I would note the South Atlantic anomaly is now in the Central Pacific instead of over the South American continent. That's where it is currently. Enjoy. Enjoy these facts. No, it does not portend doomsday. It seems to move possibly in a seasonal fashion, which would be even less spooky than if it's just moving around based on something going on deep in the mantle or something like that, right? Is it going on in the outer core, the inner core, deep in the mantle, transitional zones? Who knows? But since we don't really know how Earth's magnetic field is generated, at least not in a way that we can sort of have predictive value for it, but there it is. Super obvious that the South Atlantic anomaly is right here, just off the South American continent, near the equator. It looks like it's moved south, actually, a couple 100 miles there, but it's still kind of close to the equator there. So, I don't know. Facts. Next, let's take a look at the sunrise over this blue globe, shall we? We're going to cut out about 30 of those frames. We'll cut out 25 frames. There you go. There is the sunrise over the lovely Atlantic and the Eastern Pacific, as it were. You know, this area down here, Argentina, they look like they're on the same time as New York, I think. Pretty close. Anyway, there is the scenario. Isn't it awesome that we have access to such fantastic data? I mean, just look at that. It's gorgeous. Just gorgeous. Continuing right along, too, take a look at the U.S. water vapor picture. That's what's up. Clear skies over most of the country here, likely. Maybe not Arizona, New Mexico, Utah, and Colorado. Look out, Colorado, hot air capital of the world. There's snow coming your way as I see cold air coming down. Look at that. Cold moisture coming down, warm moisture coming up. Yowzers. We're going to show some forecasts. But first, the U.S. Doppler radar. Yes. It measures the motion vertically of water droplets. Yes. Pacific Northwest getting kaplastered. It is a very, very moist area. The Great Lakes region getting buried. And some weather there moving out of Halifax. Shout out to SwearNet. Yeah, swearnet.com. If you don't know what it is, I'm not going to tell you. So here's windy.com showing temperature. And check out the temperature in central Indiana, folks. I clicked on Indianapolis. That was my bad. How about -2 in Crawfordsville? How about -4 out in the plains? Dude, it's a good thing nobody lives there except cornfields, because yowzers. That's chilly. The mountains of West Virginia showing some pretty cold temperatures too there. Check it out. 10 degrees Fahrenheit in Hazleton, Pennsylvania. So cold temperatures indeed. And let's head to tropical tidbits. As we have some warm weather coming to Lehigh Valley. So first we're going to look at thermodynamics. That's the 2-meter temperature. And we're going to show a 72-hour forecast here because we don't want to count our chickens before they're hatched. Or our dollars before they're transferred to our accounts. Since there's plenty of fraud and scams going on where people promise they'll pay and then they don't because they're fucking deadbeats. It's a delight. It's a delight. Merry Christmas. You might be going to prison. All right, so there is the 72-hour temperature forecast, and it's going up to 37 in the next couple days here in eastern PA. That's going to feel like spring. I'll probably be outside sunbathing, shirtless. All right, so that's your 72-hour forecast for a temperature. We're also going to show the total positive snow depth change forecast for the same period and the same model. We're showing the GFS model if you're wondering, and there is the 72-hour forecast for accumulated positive snow depth change. So it's actually not going to hit Colorado that much. This is the hot air capital of the United States right here, Colorado, as there is a lot of cult activity and a lot of nonsense coming out of there with a giant megaphone behind it. Some heavy, heavy snow there forecasted for Washington, Idaho, and indeed Montana. Besides that, things are pretty chill. A little bit of heavy snow making its way into Oregon. Shout out to our viewers from all around the planet. Next, we're going to show surface winds, and there you have them for the U.S. You can see once again the Great Lakes are accelerating winds, this time to the northeast instead of to the southeast. Is it creating lake effect snow? Probably. Let's see. Yeah, there's cold air coming in as well as warm air. So there's like a mix there. See that? The main flow is coming from the north, but then the winds are going this way and crossing right across that. So as this moisture makes it down there, it's creating massive pressure gradients. So we'll show the pressure gradients. Don't believe me? Okay, well, here they are. And you can see them right there at Lake Michigan. Big pressure gradients there. Because here, it's 1,031 hectopascal. And up here, it's 1,014 hectopascal. And over here, it's 978 hectopascal. Not quite hurricane force, but... And of course, we do have an anticyclone down here with a mild clockwise rotation. Pressure down there up to 1,039 hectopascal. So yeah, there's the pressure map, and you can see a bunch of Arctic low activity. Some Antarctic lows. If you're interested in where the world's largest waves are, I find it interesting. Let's see. This will show you the direction of the waves as well as the height. So there's some pretty biggies down here. Those must be like 25 footers. 25 footers right there. There's the key. Got any bigger waves than that? Yes. Yes, we do. South of Kamchatka is where the world's largest waves are. Right there. About 27 footers. So the seas are pretty calm right now. It's actually not that bad of a day to be sailing the world's oceans. Some nasty stuff up here. 25 footers. Not the best day to be on a Viking longboat. We'll close out this video with the jet streams. So here are the surface winds. And here are the 250 hectopascal winds. Major jet stream convergence happening right here. Look at that acceleration. The winds there are blowing 174 miles an hour. Making for some fast transatlantic flights. It's a great day to fly to the Azores. Yeah, the Azores, these islands out here, which are the property of Portugal. If you're into pirates, you got to go to the Azores. Anyway, here are the jet streams of the local, here are the southern jet streams as they circle Antarctica. And just a consumer tip, folks, Antarctica, the Southern Ocean, is a very special ocean because of one thing. It is a ring. No other ocean is quite like this because the Southern Ocean it's encircled by the jet stream all year round, and it just goes around one landmass right through here, the Drake Passage, and then it just constantly goes around. If you look at the currents, as you can see, there is a ring current that goes right around Antarctica. Very strong, very, very strong currents here south of Africa. Look at those. Those are bonkers. 3.5 miles an hour. That'll take you out to sea fast if you'd like to be eaten by sharks. All right, so yeah, there are the jet streams of the southern hemisphere. Here are the jet streams of the North Polar region. Very different, folks, very different. Because, you know, there's land in the way of the jet streams. So yeah, the Earth, it largely does have sort of like two totally separate environments. Like the southern hemisphere is almost like a different planet when it comes to weather, because the ocean currents are so different and the air currents are so different that even from a geologic perspective, the southern hemisphere and the northern hemisphere, they kind of have separate climates. Thanks for leaving a comment, Kathy. Oh, nice. You've been to the ASOS 81 to 84. That's amazing. Do you speak Portuguese? That's my next question. All right, so yeah, there are the jet streams. Now we're gonna show the jet streams from a global perspective. This part's for our friends in the Eastern world. Shout out to Kimberly and Dirk and our viewers from Australia. Shout out to our viewers from Southeast Asia. Here's what's going on in the Central world. It shows the Near East and Europe and Africa. Very cold air being pushed down here into Egypt. Yeah, it's a cold day in Egypt right now, as Arctic air is coming straight south. And it is a warm day in Italy and Spain. Last but not least, the jet streams of the West. Shout out to our viewers from all around the planet. And it's about time to close this mother out. We'll cut to some images of the closest star and then press mute, let this thing run for a minute, and say bye-bye. Thanks for tuning into the stream, by the way, everybody who has. Congratulations on realizing the channel exists. We're frankly surprised that you've found it with the pathetic and disgusting state of censorship and other various frauds on the internet, as big tech organizations mislead end users, investors, their own employees, regulators, judges, law enforcement agencies, and themselves about being the pioneers of new technology. They think that they're breaking new ground in AI, which is adorably idiotic. So anyway, the NASDAQ is a bubble. See you soon here at the Smash News Network, least busted name in news. And until next time, I've been your host, Dan, aka Smash-O-Mash, signing off from stating facts. And until next time, may the solar wind be at your backs.